Okay, my friends, get ready. Who does not love a mystery? Well, what's this? The Centaur, who is a half human and half horse. Despite intensive scientific analysis, this head remains a mystery. And what head are we talking about? This head right here. This was in the Parthenon, and it was removed from there back in the 1600s and brought to Denmark. And they've been studying it ever since because of these brown stains. They can't understand what is causing these brown stains. And they've done some very good research, but this mystery remains. They can't figure out what this chemistry is, what these layers are, what this fibrous tissue is. They just can't figure it out. This sucker was alive at one time. I'm going to show you the evidence, and then you try to dispute it. I would love that. Okay, my friends, this is what happened. I have been slaughtering academia, saying these things were alive, and I am showing the evidence, so now they're fighting back. This is just all within the last couple of days. 5 days ago, 4 days ago, 2 days ago, all about the centaur's head and why this brown stuff is coming out of here. Nobody can determine why. Look at this. 5 days ago, Science Daily. 4 days ago, whoever that is. Springer opened a couple days ago. Here's another one a couple days ago. They're all from just a few days ago, 4 days ago, 4 days ago, 4 days. These are all fighting back against my allegations that this was biology. Now, I'm going to prove to you it was biology. Here's 4 days ago. They were all trying to 5 days ago, demystifying 4 days ago, 4 days ago. They were 1 day ago, 6 days ago. They're all over the place. They're trying to put up a fight against truth. Let me show you the truth. All right, we're going to get really deep into this, but here's what I want to show you. This is nothing more than membranes. They say the analysis of the brown stain on a centaur head in Denmark. And they did some pretty good analysis of this. They got the chemistry, they got the microscopy, they got spectroscopy, they got the whole shooting match. And here's what it boils down to visually. I'll tell you, this is crazy, because I just finished about these membranes, which are phospholipids. You see this phospholipid bilayer? 2 layers, and in between there's a fluid-filled highway that runs through the whole body, and you are built in layers just as I am. And every one of them is separated by a membrane, and membranes have these P is phospholipid layers. Now, they're also coated with aluminum silicates. There is nothing in feldspar that is not an aluminum silicate. All right, so aluminum silicate, you see this right here? You got phosphorus, which is phosphorus bilipid layers, and then just below that you got aluminum and silicon. And what membranes are made of is phosphobilipid aluminum silicate is the feldspar. That's what makes feldspar. And these are special coatings. They're like rubber bags. This is DNA tested, CAT scanned. This is a human lung. All right, this is this kind of stuff that coats it. What happens in membranes is they have to allow fluid this way and that way, but only certain types and in certain times and conditions. What's happening is in that head, the stuff is leaking out of here. The brown fluid. It's really basically, I think, more lymph. The lymph fluid than it is blood, because the lymph is also brown, and it's basically leaking out of here. Okay, so what have they found out about the centaur? Well, there have been many attempts to explain this brown film. In 1851, Liebig performed the first actual scientific investigation and determined the brown film contained oxalates. All right, those are salts of oxalic acid. Salts are just crystals. This has been confirmed by later analysis, but the origin of these oxalate crystals has remained a mystery. They just can't figure it out. So let's go a little further. All right, so here's what happened. This team was allowed to take 5 small samples from the back of the head. The samples underwent various analysis in their laboratory, including protein analysis and so-called laser ablation, inductively coupled plasma mass spectrometry. And that's where you can tell what molecules exist in what layers. And this was very, very illuminating. We found no traces of biological matter. What they were looking for is algae and stuff like that. They're not going to find growing little organisms in there. It has the chemistry of a membrane. So they were looking for what's the biological matter that would have created this brown layer. They think some organism is spewing that out as a byproduct of life. So only from our own fingerprints they found something that looked like life. Perhaps a bird egg that broke on the marble in ancient times caused these things. See, they just have no clue. It doesn't prove that there never was a biological substance, but it significantly reduces the probability. No, it doesn't. Making the theory of a biological organism less probable now. See, they're trying to say this is not biology, it has nothing to do with biology. It is biology, it was a creature. Similarly, it is now less probable the marble surface was painted, according to the researchers who also specifically searched for traces of paint. And they are naturally made from natural products long ago, and no traces of such ingredients were found in this brown stain. Now listen to this. I'm going to show you the visual evidence that supports everything I'm saying. The mystery remains. Through their investigation, the research team also discovered that the brown film consists of two separate layers. That means a bi-layer, and it is loaded with phosphorus. These two layers are approximately equally thick, around 50 micrometers each, and they differ in terms of trace element composition, just slightly. However, both layers contain a mixture of those oxalates, and those are called wettolite and wibbolite. The fact that there are two distinct layers, one and separated just equally distant from the other, argues against the theory they were created by migration of material, such as iron particles, from the interior of the marble. No, they did migrate through these membranes. It also contradicts the theory that they resulted from a reaction with the air. So they're just completely lost. They have no idea what to think. It says air pollution is unlikely because it's been indoors and all that business. As there are two different brown layers. Here's the key, in quotation marks. Two different brown layers with different chemical compositions. It is likely they have different origins. No, it's biology. It's called, I can't remember the two different heads of the bilipid membrane. One of them opposes water and one of them attracts water. I can't remember the names. This could suggest someone applied paint or a conservation team, but since we haven't found traces of the substances, the brown color remains a mystery. And that's the end of it. They have no idea what it is. I'm telling you right now, I'll show you exactly what it is. It is the membranes. You see this? Membrane associated crystallization, hardening up of calcium oxalates in vitro. That means inside a creature's body. Johns Hopkins University. I went there for genomics. All right, I showed you what this is, the phosphorus bilipid layer, phospholipid layer. This phosphorus chemistry, and then you have these oxalates. And don't forget, phosphorus is the P. Silicon aluminum is feldspar, aluminum silicates. All right, now watch what happens here. Okay, probably the best way for you to think about this is there's two layers, and both contain these oxalate minerals, and I'll tell you about those in a second. Now, their two layers are approximately equally thick. Those are the two bilipid membranes. They differ in terms of trace element composition. Trace elements are the little bits and pieces that are amongst that phosphorus. And that means they make one side hydrophilic and the other side hydrophobic. One repels water and one attracts water. That's the difference between the two layers. Other than that, they're both phosphorus. Well, phosphochemical. All right, here's the layer I'm talking about. This is that layer. and it allows stuff to come through both directions if the stuff is the right stuff. It has to be correct. And the body fluids apparently are leaking out just, I believe it's the lymph fluid, which is the lymphatic fluid runs around through your body and collects up stuff and it delivers it to the lymph nodes. But it's a complete fluid-filled highway that is everywhere in your body. It has to pick up all the trash. They're like trash collectors everywhere. So it's seeping through where it's hanging down. You can see where his arm hangs over, and it's at the bottom of his arm. That's where the blood is leaking down. It's lymph fluids, actually. And they are in there, I'm telling you. Let me just show you something, how well fluids can be preserved inside a stone. Let me show you something. All right, you see this? A friend of mine went out, he took the 15-minute challenge, went out and found this heart. And this is the fascia that coats around it, and this is that membrane-ish area. There's a membrane between this and here, and that's right in here. Now, this is the fascia that coats everything. All your organs are coated with it. Again, this was, I don't know if I showed you this, but this is DNA tested and CAT scan and everything. And it died flat in the flood. And the same thing with this. This died and was disassociated from a body. Now this, I believe, is the lymph fluid. And this is more or less the vein area. And this is the red arterial blood. And he just saw this red spot and he whacked it with a hammer and popped right off. And this is all the plumbing that drops right onto the top of the heart. Now I'll show you what happened after an hour or so sitting out. This became oxidated or deoxygenated, all right, because it normally has 3 oxygens attached to the iron. 2 oxygens, you're in this color. This, I believe, is the lymph, and I believe that is what is this brown stuff that's coming out in the Centaur. All right, this right here is a heart, and you have red blood, and then you have the blue blood, which is the pulmonary, the vein blood, and then you have the lymph. And I believe this is the yellow one, and then there's the big red one, and then there's the dark here. And I'm going to show you what happened after. Well, let's go back and look at it again, and then I'll show you what happened after it got oxidated for an hour or 2. All right, this sits right on top, just like, bolted right on the top, and has the valves and tubes and all this stuff. One of them ran out of here and it's sealed off, but he saw the red, popped it, and it opened right up. So again, I believe this is lymph, this is vein, and this is artery. Now, after an hour or 2, this moist blood, first of all, turned hard, and secondly, turned black. You see it? These are all these plumbing going down through those tubes, running out, and all these popping out through your body. Now, this originally was the red blood. This is the oxygenated side. And I'm pretty sure this is what's leaking out at the Centaur Head. All right, don't forget this statement. The investigation, the research team discovered that the brown film consists of 2 separated layers. All right, these 2 layers are approximately equally thick, this layer here and this layer here, and they differ in terms of trace element compositions. All right, so this has a little bit different stuff than this does, but they both contain a mixture of oxalate minerals. All right, well, what's an oxalate mineral? All right, we're going to get deep into the chemistry, but remember this: calcium, which is bone-ish material, oxalates crystal membrane interactions. Membrane, they talk about these oxalates and membranes quite specifically. And that's what they look at it as a disease, basically, where these calcium deposits are collecting, like in your kidneys, kidney stones and all that stuff. All right, so don't forget calcium oxalate again with the membranes associated to the membranes. You see this? Look, they're just slaughtering an hour ago, despite intensive, and because I've been going after them. And this one here shows the blood leaking out of here, and it even shows the tissue and everything else. They say it's a fibrous tissue It's just his body. It was 1 day ago, an hour ago, 3 days ago. They realize, 6 days ago. As anybody who's been around me knows how aggressively I've been pushing the fact that we just don't understand these things that nobody looks at carefully. You have to, and they did a very, very good examination. I'm going to show you right now the chemistry, the different layering of the phospholipids and all that stuff. Okay, my friends, I am going to show you this exact same thing in a microscope, which I have here. And I'm going to explain to you right now the chemistry. They did a fabulous job at examining this little slip from the Centaur. Now, I have something that's very similar here, but let me explain to you the chemistry which relates to the biology. All right, so get ready. All right, let me just try to explain to you what you're looking at in totality here, because it's a little bit overwhelming. This is the sample in its entirety. This is basically this sort of stuff. And down below it, it changes. All right, so this is this. Now, what else are we showing here? This and this shows where the silicon is. That's a Si. Silicon is in the outside, very, very dense. In biology, it's 50 times more dense on the surface areas of your skin than it is inside. Silicon is tough. So that's showing you where the silicon exists. Now, what is this? This is iron. And I don't know if they're showing iron is everywhere or iron is nowhere, but there should be some iron in there because there's blood. Blood will be in here. Now, maybe the blood was gone, iron is gone for they did something to remove the iron so that it could petrify quickly. I have no idea. Because I think this was done as an art sculpture, basically. Now, so we're still looking at the same thing again. It's always the same thing, the same thing, the same thing. So this now, we know the silicon is in your skin. There's no question about that. Now, again, what's now this? This is calcium. Calcium there's a lot of calcium because that's a durable product. CaCO3, calcium carbonates, are tendons and stuff. So this is tough stuff. You can pull and all that stuff. That's what your skin does. Now we come down here to aluminum. You see where the aluminum is? It's all in here. Aluminum silicates. The silicon coated the whole world during the giant flood, and the silicon attached to the aluminum, and it caused the aluminum silicates, and that's what it is, aluminum silicates. You see here, silicate, aluminum, they're both in the surface. Aluminum silicates, it's feldspar. Now, what is this? Down here, that's your phosphorus. Where is the phosphorus? It's in the bilipid membrane, right there, 2 layers. That's where the phosphorus is, right in between the 2 layers. That's it, my friends. That is a membrane. Now, I also believe this could very likely be a blood vessel. Possibly. It's very hard to tell. These pictures are not as good as I'd like to see, but they could be checked. I think that could very well be a blood vessel. Now, I'm going to show you what I have here in my shop that mimics the same thing. It's the surface skin, basically, or it could be the fascia of something. In this case, it appears to be the guy's skin. All right, so let's take a look right here again. This is the skin, basically. This is the phosphorus layer, the biphospho layer, which is the bilipid membrane, and then below it is the body tissue. Remember, right there is the membrane, right in the middle. All right, as you can see, here it is right here. There it is right there. That is that bilipid layer. I discovered this, basically. They didn't realize this was a fluid-filled highway. I could see it in my mud fossils, and I explained to everybody long ago that this was one worldwide organism inside your body, one, body-wide organism, which was all tied together. It was a fluid-filled network, and it attached to everything. And that's where I believe the lymph flows. And I believe that's what's leaking out. And it's where, like, this is the skin. If he's upside down this way, this stuff is going to fluid or go that way. So in other words, let's tip this guy upside down. What's going to happen? The stuff is going to run down here. Whatever can get through that membrane is going to start to show up on the surface, these brown oxalates. These brown, whatever they are. All right, and they are this stuff here. This brown stuff comes out, and they can't figure out what it is. Okay, this is the clincher, my friends. This is optical microscopy, where they're really looking at it close. They're talking about these two brown stained layers, similar thicknesses, each approximately 50 micrometers thick. The two brown stained layers can be viewed in detail, and I will show you them in detail. Both layers feature several red and black dark brown grains with a wide size distribution of both the red and dark brown grains. Red and black are blood. Below the brown stain is seen a layer appearing white in both optical microscopy and backscattered electron imaging. So it's a white looking layer. The white layer has a varying thickness and a filament-like appearance. Filament. All right? But with an overall average thickness of approximately 50 micrometers. The white layer is somewhat enriched in P compared to the other layers. The white layer is the membrane, which is the phospholipid membrane. That's what I just said. This is the phosphomembrane. This is the white layer. This is the layer that they can't explain, and it leaks through here and lets this brown stuff come out, which is the lymphatic fluid. There's a lymph fluid running through here, and that's what's leaking down, because it's only where it's leaking down. It's not coming up. All right, don't forget, this was just announced in 2018. By the time they autopsied people, this was flat and drained of its fluid, so they thought it was a thick wall, and obviously it's not. It's a fluid-filled highway. So they call it a new organ, which is this. And I posted a paper on this in 2015. It's on academia.edu. It's called Fascia Facilitated Fossilization, because I found that the fascia, which is the coating, is what protected everything. And it's because of this chemistry. It's this phosphobilipid layer. And as I'm going to show you the chemistry, or I already have, I got interrupted a couple times, but this is this double-walled layer that separates your body from, the skin from below, and that's what's on that Centaur. And it's leaking stuff out, but it's leaking it on the gravity side primarily. See, this is exactly what I would expect it to show up here, where that lymph fluid is draining down and collecting here, and also coming out down to this shoulder. It's a fluid movement, and the membrane is allowing that lymphatic fluid to come through there. This, I believe, is just sort of migrating over. Or it might have pushed some, lymph fluids into here, which are being expressed right here. But this is gravity, first of all, moving the fluids down and forcing, I believe this is forcing it into here, causing this to also exude a little bit of brown. Over here, it's not doing it because he must have had his arm dyed hanging down this way. It was full of blood. When they twisted it over this way, the blood that was in there is now draining back down here. That's the only thing I can think. Okay, this is the stuff. This is my sample right here I have in a microscope. Now, whoops, there it is right there. Now this is just sawed right off, but this is the part right here that is the part right there. And below it is this part right here that is the gray, dark part below. So the interface between the two is a membrane. And that's why I say the interface between both. I'm going to show you that, and I can show you that probably will create catalase right in that spot, because it showed the catalase breaking down to hydrogen peroxide. So let's take a look at that. All right, what I want you to look at is this layer right here, that little line between this and that. That is where the membrane should be. Now, it's not really obvious when it's dry, but when it's wet, it will be very obvious. Now, I'm going to put some hydrogen peroxide on there, and hopefully we're going to see a good catalase reaction. Will be a big foaming right in that spot. Now, I have to move and bring it back. Here goes. All right, let's see if we got the hydrogen peroxide. You see how nicely you can see the separation now? I'm not seeing a big reaction though. I would have expected more foaming here, which normally indicates a lot of catalase, which is normally found in this layer. I don't see it foaming up though. Normally you're going to see that foaming up. I'll show you another one. I don't know what's going on with this way. I'm not seeing any foaming at all. That's hard to explain. Hard to explain. You should see something foaming right. You should see some kind of action going on right here. A little bubbling. Well, actually, I am seeing a little bit. Very low. So little, I would say no. So as far as I'm concerned, this was a failed test. But you can obviously see the layer here, and then the membrane would be here, and then you're into your good tissue. All right, if this one doesn't do something, I will freak out. It's got a vein and an artery up there, and you can see the separation. This is, I think, some kind of a muscle area. And that's the separation zone between this piece, this, and of course the outside layer, and you got your vein and artery right there. This I know is it has to foam up. I haven't tested it, but I'll fall over if it doesn't. All right, this goes beyond outrageously cool. I am going to put some hydrogen peroxide in here. No question whatsoever, we're going to see all kinds of bubbling, and I would expect to see a lot of foaming coming out of here. Because this, again, is that outside layer, and then you get into the tissue inside. And that is basically, I think, could very well be right there, just like that black spot right there. And then, of course, you're into this dark stuff, and the top is all the lighter color. All right, and you'll see this will turn lighter color when I put the hydrogen peroxide on there. All right, get ready. I am going to move the scope out and put the hydrogen peroxide in, and then we'll come right back uno momento, and I mean like right now. And what do we see? Watch this thing foam up like crazy. It's going to take a second to penetrate into where the red, see it starting to bubble? Now down in here, I would have expected to see a little more foaming. But you see how this is a different color than this over here? It's a different tissue. See it? It's foaming, but it's not like I would expect it. It might have just ate it up too quick, too. Hold on a second. Alright, now that should bubble pretty good. See, it's starting to bubble pretty good now. And now we're getting bubbling coming down from inside. See it bubbling up there? Boom. Watch up here. This is where we're getting a lot of action. See the bubbling coming up now? That's where I expected. In the membranes, you got a lot of that catalase. All right, and we should see some good bubbling, but I'm going to really load it up. See them popping now? That's a lot of oxygen boiling up out of there. Now watch this. I'm going to hit it with a bunch more because it eats it up quick. Its job is to remove that excess oxygen. Let's see what we can get now. I would expect to see some good bubbling, and as we shall see right now, here it comes. Pow, pow. Boom. It's actually shooting out some blood. Red blood cells are kicking out of there. See them? Now we're getting some good reactivity. That's coming from down inside that membrane. And that's what the job of the membrane is, to use the catalase enzymes to kill off anything that's coming through. Those are called reactive oxygen species. All right, and they react with your chemistry and kill it. See it shooting out of there? Boom, boom. The more I put in there, the deeper it will flow inside, and then it'll really start to bubble. Right now it's starting to bubble pretty good. But I don't think you want to watch it all day long. Sometimes I do, just to see how much it will do. Because it's truly amazing. These catalase enzymes still exist in these rocks that have been obviously kind of well aged. Now I'm surprised we're not getting much more out of that. I'll bet I could get some out if I scraped it out. No, I'm not going to bother. You could see the catalase reaction. You don't have it bubbling all over here. It's bubbling from down inside where the membrane is. Just take my word for it. You see this? This is the reaction we're getting between this membrane here. We're getting a lot of bubbling, and we're starting to get that foamy stuff coming out of the membrane. That's what I expect from a membrane. Right on that line. You see that foamy looking stuff? You see all this bubbling out of here too? That's that bilipid membrane. And now we're down into the tissue that has some blood in it and has some all that other stuff. And out here, we're at the skin. And this layer right here, and this layer right here, between the two of them, that's that protects you. And that's that white fluid-filled highway, which is filled with oxalates now, which are crystals. And that's precisely what you see here. There's no difference whatsoever, basically. Let me even turn it to the correct orientation. Right, there's that fluid-filled highway. There's those filaments that they're talking about. It is what it is. You see, that's your immune system actually functioning right now, killing off these things that are trying to invade. You're not seeing anything happening down here. You see them? Look at them lighting up and flashing and everything. Look at that. Look at that. Isn't that something? Boy, that's the first time I've seen it in such amazing, all flash, all at, look at that, all at once. Wow. I tell you, I see something new every time I do this stuff. Fabulous. This is just over the top. I'm thrilled. This is right here. Is this right here? It's right here. That's it. Between here and way up at the top. The bottom here is this. And way up at the top is the outside layer of your skin. In between is this white layer, which here it's turned dark, but that's where it is. And there's the two separation zones. Isn't that something? Look at that. All right, if you look carefully, I believe, and I'm pretty sure, that that is where there was some blood, you know, a little blood vessel, and that too. And here they are right here. You see this? This looks like reddish looking to me, which is what I would expect from something here that would be an artery type, the red blood. And that looks reddish. I don't know. This one over here is this one, and that's the black one, which would be for the vein. And normally they come very close to each other. That's just speculation. But this is basically the skin. And then you get down to the fluid-filled highway, which I just showed you a minute ago. And then you get below there into the meaty stuff, which is the gray area, they call it. As far as I'm concerned, I can't see any other conclusion than that thing was alive. All right, I think I showed you pretty well that that white layer has a varying thickness and a filament-like appearance. I showed you that. An overall average thickness of such and such, the white layer is somewhat enriched with P, which is the phospholipids. P compared to the other layers, because they're phospholipids, that particular layer. Okay, so this is my response to the analysis of the brown stains on the Parthenon Centaur Head in Denmark. And this just came out, I guess today or yesterday. And it's a pretty good paper. And I think I've addressed all of the major points to it. And it appears to have been actually alive at one time. Okay, I came across this, very nicely done. They only have 420 subscribers. I just subscribed. It's called A Square Solution. Now, I don't know how much they're doing yet, but I did subscribe. And this tells the story of the Centaur's Head very quickly, nicely done. And I'm just going to cut in here at like 20 seconds. Here it goes.
As captivating as the mythical creatures it portrays. Yet, the Centaur Head is more than just a relic of a bygone era. It is a silent enigma that puzzles scientists and historians alike. You see, this revered artifact, along with other marble fragments from the Parthenon, bears a thin brown film. Known to contain oxalates, this film was first identified in the mid-19th century. However, the source of these oxalates has remained elusive. Intriguingly, recent investigations have revealed no traces of biological matter or paint in these brown layers. They consist of two separate layers with distinct chemical compositions, suggesting different origins. Yet, the mystery of the brown film, much like the Centaur's Head itself, remains unsolved. Despite being an artifact of immense historical significance, this Centaur Head hides a secret that continues to baffle scientists. In the quest to reveal the secret of the Centaur Head, researchers have embarked on an exhaustive investigation. Our story takes us to the University of Southern Denmark, where a team of researchers have dedicated themselves to revealing the truth behind the brown film on the Parthenon marble fragments. The mystery of the brown film is not a recent curiosity. In fact, the presence of oxalates in the film was discovered way back in 1851. However, the origin of these oxalates had remained unknown, a puzzle waiting to be solved. The Danish researchers took up this challenge, turning to modern techniques in their quest for answers. They scrutinized the film, peeling back its layers in search of any clue. They left no stone unturned, examining it for traces of biological matter or paint that could possibly explain the brown coloration. What they discovered was as intriguing as the mystery itself. The brown film, it turns out, consists of not one but two separate layers. Each layer has a different chemical composition, suggesting different origins. This discovery added a new depth to the mystery, raising even more questions. If the layers have different compositions, does it mean they were formed at different times or under different conditions? And where did the oxalates come from? And yet, despite these intensive scientific analyses, the source of the oxalates and the origin of the brown color remain a mystery. It's a reminder that even with all our scientific advancements, there are still puzzles that elude us.
Okay, they did a nice job. Now, speaking of the oxalates, I am going to show you, I believe, some oxalate crystals and where they form and how they form. And we have to look at all of the evidence instead of immediately suppressing evidence that comes up. And that's what's happened to my stuff. It's been a lot of years now. So let's see if we can discover the source of these oxalates. All right, check this out. I believe these are those oxalate crystals. And this right here is a fingertip. And that's the blood coming out of the end of the fingertip. That's blood coming out of the end of the fingertip. These are those crystals. And this is also blood here, all that coagulated because it died laying down this way. This was down. Now, I'm going to turn it over, and you'll see the fingernail up at the top. All right, this is what's called the apical tuft right there. This is the fingernail. Let me put a little water on there so it becomes... Water always makes things look better. It'll get real shiny for a second, but then it should get better. Alright, so that's the top. You see those little dents there in the center? That's where the tendons lock in. It's an apical tuft. I have some here that have completely eroded out. Well, I have one anyway. And hold on, let me home in on that. Alright. That's the tip of the finger. It's not much different than my fingers, about the same size. All right, and it died laying with this side down, and this is all blood. That's just blood that congealed here, see? It's just red blood. And this is where those crystals form. It's in the skin, basically. And there's the fingernail right at the top here. Now the vein and the artery and the bone you can see at the bottom. I'd have to home in on it and put some water on there and stuff. But it's there. This is completely transitioned into crystals, basically. You see, there's the center core of where the bone was. And there's going to be a vein and an artery and all that stuff. Let me put a little water on it. You should see a pretty dramatic transition, I think. Who knows? Let's see. Water really makes a big difference. Alright, see, now we're seeing some colors come out. Come down here close. You see, this is what happens when they transition and they stabilize, when they take on whatever they can get to become stable. But that's where the skin was on the outside. I believe that's the artery. And that's, of course, the bone, I believe, in the center. And way out on the other side is the vein somewhere. And these are the tendons that run up the center. Anyway, hopefully you understand that this is a fingertip, and it's just what it is. And this is exactly what you were looking at. Hold on, let me come over here. This is exactly what you were just looking at. And the blood ran down here. The artery side is here. Arteries blow right out. So this thing died laying like this with a whole bunch of blood running down. And I think the same thing happened with that centaur. When he actually died, they must have repositioned him. And when he actually died, his arm had all of its blood running down into it, and it was saturated with blood. Then they set him back up and wrapped his arm around the back, and all that blood sooner or later made its way out. This, of course, just leaked right out when it died, but I don't know. There's all these, see all those little crystals in there? So anyway, that, as far as I'm concerned, a centaur was alive. At one time, it was alive. Well, okay, I've shown you a lot of stuff, and I've shown you that blood pools and it drains down through the arteries. So somehow he must have had a ton of extra blood in his arm. All right, it went before they propped him up, and I would say they probably propped him up after they were dead and somehow turned him solid. Now, there's a ton of extra fluids in his arm, and it looks like it was so much that it eventually just worked its way down into this whole area here and flooded this whole area, because you'd pinch off your jugular vein or whatever, the main lymphatic system or vein or whatever here. So it would stay up here until it sort of leaked out through the membranes. That's all I can think of. And they showed the membrane. I mean, there's no question in my mind whatsoever. They're membranes. And they're from a living creature. Now, here's where they took the samples. Remember, he's got his arm wrapped around the back of his head. They let him take it from the back of his head, just a couple tiny little spots. And here's where they took him. Whoops, I think I got a better shot. Well, maybe not. All right, here's where they took him. One spot here, a tiny little spot there, a spot right there, one here, and one over here. But it doesn't matter. It's all skin. And it's all the same stuff. And it's skin. And you can see, if you look real carefully, you can see the wrinkles in the skin here and everything. And this arm is twisted back. Now, they painted this and then put this on here. That's paint. You should probably, if this was cut back, you should probably be able to see something that relates to the structure of the bone in here and so forth. You won't see it clearly, but you'll see something that will show a membrane-ish area around, because that's the thing, the membranes are the key. Just like this is nothing more than a membrane. It's separating on its membrane layer. Okay, my friends, as you can see, we have a lot more to go over about membranes and the chemistry and where they show up. But I believe I have shown enough to make my case that the Centaur head was more than likely alive at one point in time, and it can be looked at a little closer now. I look for the fractured places. They're looking for the exterior. I look for when the fractures come. This is what tells you where blood vessels were running and so forth. But again, they painted over this one. Otherwise, you'd probably be able to see something here. They painted it so they could get their letters and so forth on here to designate whatever. And at the same time, they sealed it over. Make sure nothing can leak through there, guys. Yeah, put some sealer on there and paint it. Well, they're only looking at surface. I go for the fractured points, where the broken points are. Just like Caesar here. I can see that's it. That's a goose. There's this beak. There's this little nostril-looking thing. His eye is right there. And there actually is his feathers. That's where his feathers are. However, you go past this stuff, which is the feldspar, and you get inside to what they call marble. Here it's basalt. But there's his neck. You see, there's his neck. And there is the artery leading up to his head. And if you know how to look at it, you can see his neck is right there. If I put a little water on it, you see it even better. But he died in a great flood. And almost all my stuff did. And there's a bone which has all the feldspar on it as well, which is nothing more than this. And that can peel right off of there in the right conditions, in the right... Skin peels right off. Let me show you some... Well, forget about this. This is too much. It gets a little overwhelming, my friends, because the things I'm going to show you are just staggeringly overwhelming. So I think I will hold off on it for today. All right, I love you all, and I think I've made my case. I think I have made my case that this guy, this centaur, had been alive. And I think the testing can be done now, given that it would be looked at as an actual possibly living creature. Because there's a lot more you can do to look at it. You don't have to cut things open and all that. They gave them little flakes. That's fine. The chemistry was fabulous. This is fabulous. I mean, I can see exactly what it is. There's the skin. There's the fluid-filled highway, and it even has the phospholipid. This means that this layer here is phosphorus, P. That's what a phospholipid membrane is. And this layer here, the top layer, is loaded with silicon. Yes. It's not down here. It's up here because that's where you're doing all your toughness. Silicon's tough. And there's the aluminum, and there's, aluminum silicates, and the phosphorus. I mean, they did a fabulous job of researching it, but now they just have to take it another step and say, let's think about, is this guy crazy or is this possible? And I think you'll find out it's quite possible, and I think you'll find out it is exactly what has happened here. I have no explanation for it other than, as far as I've been able to determine, most of the myth appears to be factually based. I mean, I've had my giants, and they are giant, very giant, DNA tested, some bits and pieces CAT scan, and the skin peels right off just like this. You want to see? I will show you one last thing, and then I'm going to let it go for today. This is how the skin peels right off, just like the skin they peeled off to do their samples. All right, they let them peel these little pieces off. So they just took little skin samples off. That's all, and the skin just is basically stuck like a layer of. Well, let me show you how it is stuck. All right, this is a left human hand, and it is a human because I had a DNA tested. And there's a fingertip from it. I have a whole bunch of pieces from this. Now, that is a left hand laid out like this. You have the same tendon running down yours, and then you have this runs to your little finger, and that runs to your thumb. You see this grip skin peeling right off? This is what skin does. It peels right off like that. It's just like glued to it. It's almost like cellophane covering your whole body. And in the hands and the fingertips, it's a tough. I call it grip skin. And it does all the work. And it is absolutely totally infused with silicone. Now, on the rest of your body, you have finer skin, and it's not quite as densely like this. And it's more fluidy, more floppy. This is kind of tough like a glove. All right, so I'm calling it quits for today, but that shows you that's how easily that skin just peels right off. And we got a lot more to do because these membranes get quite large.